Okay, now we can.
All right.
So last talk.
All right, testing. Okay, so starting here, my talk is about developing effective testing pipelines for HPC applications. Just to give a short introduction about who I am, relatively new here. So, I first started in the HPC industry while I was in college. I joined my university's HPC institute as a software consultant, so largely in that role, I was kind of more focused on support. So in that case, I was working on like Singularity deployments, helping debug Fortran. Not very good at writing Fortran, helping build custom kernels for Jupyter, all that good stuff. And then I left for a bit to go work at another university to do some adversarial machine learning workflow orchestration framework. And then eventually I came back to my university's HPC site then as an engineer instead of a kind of support role. So more in that case, what I worked on was like building, a suite of Singularity containers that clients could consume, and then also working on like debugging tools that interfaced with like Moab and Torque and PBS and all that. And then after I graduated university, I joined Canonical. So that was probably like 9 months ago now. Kind of the start then, what sent me down this path of wanting to develop effective testing pipelines for HPC applications? Well, first, when I started at Canonical, to be frank, I wasn't very good at Debian packaging. I had mostly deployed most of my software using bash scripts, compiling from source. And so part of that is I had to write provisioning scripts. So I mostly work in cloud orchestration, deploying like nodes and whatnot onto clouds. And so I had to, develop dangerous code. So it's installing packages, making configurations, kind of setting pre-seeds in, Debian, Ubuntu. And so basically I kind of had this, dilemma of where, okay, I want an easy way to test these provisioning scripts without kind of having to go through all this manual effort. So originally, I would just, type in Vagrant, VirtualBox, or any real kind of virtual machine hypervisor, bring it up, install the script, and then once I was done with it, blow it out. And then kind of also had this issue of where I had a desire for reproducible tests, because even though I know how to bring up like a virtual machine on my system, I might be working with someone who's off of Windows or Mac, and so they don't have the same setup that I do, or they're using a different distribution, in fact. So this gave me the idea of, kind of if I'm on my personal workstation here, so my laptop. Unfortunately, my current laptop's X server isn't working, so the HDMI cable gets all screwed up. So thank you, Easy Build folks, for lending me your computer. But basically, I had the idea that what if I take a test that's written on my system and then have the ability to run it using any hypervisor I want on any operating system that I need to test that code on without any extra hassle of having to really go through supporting or teaching someone else how to bring up that instance. And basically the case of like, oh, I have to write code like Python or anything else that needs to run like Ubuntu, CentOS, Alma, or Rocky. And then kind of after working for that a bit, I had kind of an initial prototype that would bring up, basic operating system image. And then kind of as I, got more into my HPC work at Canonical, I kind of realized like, oh, okay, maybe don't want to rack up the cloud bill trying to test and deploy to AWS or Azure or even our own private internal public cloud or private cloud using OpenStack for just trying to provision HPC nodes. So for example, have like identity management, OpenLDAP, shared file system using NFS, have other options, and then also working in the case of just setting up and configuring a Slurm cluster, all kind of headless without any kind of manual user intervention. And so I kind of had this revelation where I'm like, why waste precious compute time on your HPC cluster? Because the fact is it's expensive. You're kind of paying for that tenancy. And what if you could test your simulations, jobs, applications, and whatnot on a mini HPC cluster that's kind of similar to the target platform that you're deploying, but it's more of a mock so that you can kind of get the general feel for the platform before moving on to the more expensive resources. So in this case, I started working on a custom testing framework called CleanTest, which is basically a fancy Python testing library that allows you to bring up mini HPC clusters on your local system and just kind of in general usage for developers who are in a hurry. So kind of then breaking into a question, what exactly is a clean test? Because, originally I named it simple test because I just wanted it to be really dead simple, but for some reason PI wouldn't let me register that name, so clean test it is. So basically, it comes in 3 parts. There's kind of a different breakdown. So first, you have the bootstrap and configuration stage. So for that, it's kind of where you can register hooks and whatnot for configuring the instances that you're bringing up, or do some more advanced bootstrapping. So the example I had showed in the previous slide of where you're able to bring up NFS, Open LDAP, Slurm services and whatnot, and then be able to inject scriptlets into that. And so kind of that's when we get to the second part here, which is a testlet. Kind of interesting little word that I came up with joking with some of my colleagues, but basically a testlet is an entire Python program that's wrapped into a regular function, and kind of the idea is that they contain the full body of the test that you want to be able to run inside this virtual machine container or test mini cluster. And then kind of the last part here is the evaluation reporting aspect. And then kind of with that, I took a test, sub-test framework, agnostic approach where I know that everyone kind of has their own taste that they like. Some people like pytest, some like unittest. I don't want to sit here and make opinions for you. So, I want you to be able to write tests in the format that you're most comfortable with. Oh, that came out small, but that's okay. So kind of the first part here is the going more advanced into like what exactly is the bootstrap and configuration is that you're able to bring up example nodes, you're able to provision them. You can also register hooks, so kind of similar to anyone who's done any Debian packaging. Listening to Todd, I don't think he's still here. Yeah, you seem to have some experience with Debian developers. So, but circa 2000, yeah, it's cool. But yeah, so if anyone's ever worked with pbuilder before, kind of one of the features that I really like about pbuilder for building Debian packages is that you can have different hooks that you can ingest, or you can create that run at certain parts of the package build. So I kind of wanted to replicate that same functionality. And then kind of the general process is instantiating a configure instance. So that's like a Python singleton class object that basically takes in all that info, shares it across the whole test suite. It can bring up nodes that you need to, and then you define your hooks. So that's kind of like, what do I want to run when I start the environment, and then register them so that when you run the tests, the program knows about it. And then kind of the next part here is the testlets. So that part is kind of uses some little bit more tricky programming. So in this case, I use Python decorators and meta programming, so kind of reading class descriptors and whatnot, assessing the current state of the program. And what the decorators do in this case with the meta programming is that rather than having that function run locally, instead it kind of takes out the body of that function that you defined, and then it injects it inside of the container instance and runs it there. So the idea is that you could be working off of an Ubuntu machine, but you're developing for a cluster that's running Rocky Linux. So in that case, you can just easily bring it up, inject it in there, get the results back. And then finally, the last part, evaluation/reporting. It's like each testlet kind of returns this results object, so that kind of contains an exit code, standard out, standard error. And from there, you can evaluate the results locally instead of having to instead do it inside of the container. So you could say in this case, if you're doing a spread test, so if you have I need to test this on Ubuntu 2204, 2004, and 1804, it returns a generator object of a name and a result. So, let's say that your code works on 2204 and 2004, but the version of Python on 1804 is too old for what you're trying to do, so it'll report back as an error. So, then, breaking into how does it exactly work. So the idea is that you start on your local host, so that's your computer there. So you have the host operating system, and then you have the clean test package installed as on part of your Python interpreter, which is a regular Python package. The idea is that then, as you see that dotted line in the middle there, it then makes the request to the hypervisor of your choice and tells it hey, so the user who wrote this test told me that I need to bring up a certain instance. Says that they need a CentOS image, so bring up a CentOS image for me. And then once that's done, what clean test does is that it takes that test body function and it creates a simple JSON packet, which is a checksum to verify the authenticity of the testlet. the data, which is just basically the testlet encoded, and then, or any data necessary for the testlet, and then the injectable, which is basically like, hey, when you get this data packet, here's what you need to do with it. And then once that happens, then, clean test, what it does is that it copies itself onto the container image, and then from there, it ingests that data packet, does the evaluation that you requested, and then it returns that result object back to the clean test that's on localhost. So kind of two different ways that it works. Then for like, how do you control the hypervisor? The first way is kind of Archon, which is a fancy word for director. I kind of wanted to have a buzzword in there somewhere. But the idea is that what the Archon does is that it's kind of more declarative approach to doing clean tests. So rather than, saying like, oh, automatically do this, wrap it, you can kind of direct the deployment of said mini HPC cluster, and then what Harness does is that instead of having to explicitly declare like this is the infrastructure that I want for my deployment, it just brings up an instance based on the function that it's been wrapped around. So this is a short demo video. Let's see if I can choose better quality here. Oh, don't tell me. Came as a PDF, but let's see here. All right, YouTube, sweet. Did I go full screen? There we go. Oh, settings, playback, 180p. There we go. It's a little interesting. But yeah, so basically what happens here is that just using like simple talks, in that case, I use talks as kind of the test administrator. I started a test just called LSD Archon, which basically says bring up a test environment instance. So first it starts with LDAP, so it's provisioning an LDAP node on top of LXD hypervisor. That's what I'm using here. So first it starts with LDAP, and then after a few minutes, it takes a few minutes for it to boot. Crappy hotel Wi-Fi was when I was doing this. And then, see, there you have the NFS image. That starts provisioning, and then somewhere in here, now you have the Slurm CTLD node that comes up. And now you have the three Slurm compute nodes that come up. And the idea is that then what the framework does is that it injects a testlet inside of Slurm CTLD, and then from there it uses SBatch to submit the job off to the test cluster. Takes a bit. Oop, a little too far ahead. Give it a few seconds. Yep, and then it cleans up the cluster so that it doesn't linger on afterwards. Oh, goodbye. Oh, God. What happened here?
Went on to the next movie.
All right. Okay. Well, that's not fun. Okay.
Back to your slides, or?
Yeah, I want to go back to the video. I don't know why I jumped to the other video. I just had an autoplay moment. Wow, I feel like a school teacher. Just like right to the end. Okay. All right, thank you. Yeah, all right, okay. Woo. No autoplay. All right, so basically what happens here, I'm going to full screen it so it's a little bit bigger. What? Come on. I'm an engineer, not a YouTube video player on a projector kind of guy. But what is it? Yeah, so basically all I've seen here is that the test starts, brings up the nodes that you need to use. So in that case, it was just LDAP for basic identity management, NFS for shared file system, and then just like Slurm for kind of resource management services. And then from there, it just like injects like a little test script to run. And then, yeah, if the job succeeds, it kind of copies back the results. And then, yeah, and then it says like, okay, did we get the result that we expect? So in the case of the test that I wrote, it just prints out basically like, I love doing research. And then it says like, is I love doing research in the log file for standard out. So yeah. Pretty low fidelity right now. It's mostly a lot of work went into just getting it to work and all that. Okay, now I want to go back to the slides. There we go. Hey, so Now, you saw that video, kind of overgoing some of the current limitations. The first is that I'm kind of bad at playing YouTube videos and presentations, but the next part here is that kind of right now, big issue is that there's kind of a lack of robust multi-distribution support. So currently, I mostly developed it to work on Ubuntu and work with Ubuntu. I wonder why. But you can launch Alma, Rocky, CentOS, Arch instances, et cetera, but kind of the macros, hooks, and like utilities that I built into the framework aren't really fully there yet for supporting it. And then public documentation is behind because usually I write code before I write documentation. Unfortunately, it just seems to be how it always goes. So I need to update that. And then kind of big issue right now is lack of package manager integration, so a lot of the support has been added ad hoc. So currently I support like Charm libraries, which is something that Canonical uses, and then snap packages, which are kind of controversial depending on your opinions. And then also just pips because I do a lot of Python development. But in the future, I hope to add support for like Debian packages, RPMs, Arch installs, SPAC, and easy build. So yeah, and then lastly, I'm the only developer currently, so code developed in isolation isn't reviewed as thoroughly as it could be. Yeah, I make design choices based on what I think is appropriate. So yeah, so last thing too is that testing framework I think is a lot cooler than the video that I kind of struggled to play here. So if you want to scan the QR code if you're interested, feel free. Slides are also online as well, so if you're not available right now, you can check it out. And then lastly, this is kind of a call for involvement. So really at Canonical, we're trying to start getting Ubuntu kind of geared better for HPC. We kind of know that we're a little bit behind Red Hat in the case of like network driver support and whatnot. So just if you're interested in using Ubuntu for your workflows and whatnot, we have a public Mattermost channel, so you can scan that QR code or you can check it out later. But yeah, we have a public channel for HPC. Online. So yeah, if there's something that's missing or there's kind of some reason why you're being held back on using Ubuntu for HPC, we'd really love to hear that feedback. So yeah, that's it.
Any questions for Jason? Last chance for today.
So how you're just doing, this is all Python code that's builds this system for you?
Yes.
So how are you spinning up the LXD containers?
So the idea is that in the case of LXD, it has a public API socket that uses, I think it's like Open API standard or something. But yeah, so you can make like HTTP requests out to that API that basically say like, oh, I need this instance or tear this down or set this configuration so I can install like Aptainer or some other container hypervisor inside of LXD and whatnot. So yeah, so I'm just using the API.
Any other questions?
So yeah, I'm interested in this. You had an NFS server and some other stuff. Are those pre-assembled images that you're just using? Are you building up with some kind of configuration management? Do you use Ansible to build them, or how do you do that?
Yeah. So currently, what I have is like the way that I provision. I'm using like base Ubuntu images for configuration right now, but you do have the ability to register your own custom instances and pull them in as well. But basically, I have a little mechanism built into the framework where you can write like provisioning scripts using like the clean test utility. So there's some stuff for like installing apps, running commands on like subprocesses on the unit, and then also like you can reach out to the network, download anything you need. So yeah, I'm just using custom Python scripts to provision that are. Like a script configuration management. Yes. Yep.
Anyone else? Last chance. There? All right. It's for the stream and the recording. We've been doing well all day. Let's keep it up.
Thank you very much. Would you mind, please, to move to the previous slide so I can scan my QR code correctly?
Okay. There you go.
Thank you very much.
You're welcome.
That was a good last question.
The other one? Which one are you looking for? This one or? Yeah, this one. Okay. That's all good.
All right, if there's no more questions, we can wrap up here. Thanks a lot, everyone. That was a wrap for today. the 9th HPC dev room at FOSDEM. That means if FOSDEM likes us, we can have a 10th one next year. That would be really nice. Some practical stuff. If you're leaving the room, if you see any trash, please take it with you and dump it in an appropriate place outside. And the FOSDEM team has asked us to ask you to leave the building as soon as possible so they can lock up the whole building. There's another talk going on in Janssen, in the really big room. I would recommend going there. It's a really nice way to wrap up FOSDEM, and there will be places there to get 1 or maybe 2 or 3 more beers and have some more chats with people. Thanks a lot, and hopefully see you next year.